Yet another thought on a tool that is used in combinatorics. Is the following. Very simple thought, but with supposedly the most powerful applications. Very simple thought. You might find it really stupid when I communicate that thought prima facie to you, but you'll realize the merit involved in that very basic thought. Now, if you have M pigeons and N pigeonholes, and obviously, you're going to, the pigeonholes are meant for the pigeons. So you're going to put the pigeons in the pigeonholes, not dogs and crows. So these are the N pigeonholes. N pigeonholes, your attention please, shut up please. And if number of pigeons greater than the number of pigeonholes, if M greater than N, number of pigeons greater than the pigeonholes, right? And you start to delegate pigeons into pigeonholes. Then do you realize that there must be at least one pigeonhole with two or more pigeons? If the number of pigeons are more than the number of pigeonholes, there must be at least one pigeonhole with more than one pigeon, with two or more pigeons, that is, right? Isn't it? This essentially is what's called the pigeonhole principle. PHP. This is the pigeonhole principle, PHP. Two of you must be born, there must be at least two amongst you born on the same day of the week. There must be at least two of you born on the same day of the week. Guaranteed. The days of the week refer to those as pigeonholes. The days of the week: Sunday, Monday, Tuesday, Saturday. Right? These are the pigeonholes. These are the pigeonholes. And I start assigning you are more than 7 in numbers. And I start assigning number of pigeonholes are more than the number of pigeons. Don't take it to heart. Okay. So now if I start assigning you to the days here, that is the pigeonholes, then there must be at least one pigeonhole with two or more of you. That means two or more of you must be born on the same day of the week. Yes or no? Is it not? They must be say if I have a triangle, equilateral triangle, say ABC. If this is an equilateral triangle ABC of side 2 units, this is an equilateral triangle of side 2 units, right? And say I have 4 dots available with me. These are 4 dots that I have, right? Or say 5 dots. 5 dots. Say there are 5 dots. And I take these dots and chuck in this triangle. I take this dot 1, chuck into the triangle. I take this dot 2, chuck into the triangle. Dot 3, I chuck in the triangle. Dot 4, I chuck in the triangle. Dot 5, I chuck in the triangle. I chuck these dots in the triangle. Then I claim, no matter how I choose to chuck the dots in the triangle, there must be at least 2 dots. I claim that there must be at least 2 dots, the distance not exceeding 1 unit between them, not exceeding 1 unit. The distance between them not exceed. That means no matter how I choose to chuck these dots, there would always be 2 dots whose distance does not exceed 1 unit. Right? How? What I do is, see now where is the pigeon? Where are the pigeonholes? That's the whole problem. See, when I tell you what the pigeons are and where the pigeonholes lie, then the problem is well defined. But then in most cases, you will have to figure out who you would want to call pigeons and what would be termed as pigeonholes, right? That's the choice that has to be judiciously made. So what I do is, I break this triangle into, by joining the midpoints of the side. There are 4 triangles that I have produced. Yes or no? 4 identical triangles, each of side 1 unit, each of side 1 unit. Yes or no? By joining the midpoints of the sides of the triangle, I have created 4 triangles, each of side 1 unit, 4 equilateral triangles, right? Now, how many dots are there? 5 dots. These are my pigeons and these are the pigeonholes. Number of pigeons more than the pigeonhole? That means there must be at least 2 pigeons in the same pigeonhole. There must be at least 2 pigeons in the same pigeonhole. The number of pigeons more than the number of pigeonholes. There must be at least 1 pigeonhole with more than 2 or more pigeons. That means 2 or more dots must be contained in the same equilateral triangle. That means in the same pigeonhole. And say if these 2 dots are contained there, then the distance between them cannot exceed the side of the triangle. Then the distance between them cannot exceed the side of the triangle. Yes or no?
Yes, sir.
Right? Are you there with me? Right? Now, amongst you, I claim the following. Let's say, each one of you would have friends in the class. Let me assume that each has at least 1 friend in this class. There are n people in the class and each has at least 1 friend. Right? In the class. Right? Now, my contention is that there must be at least 2 amongst you having the same number of friends in the class. I claim that there must be at least 2 amongst you having the same number of friends in the class. Not the same friends, but the same number of friends in the class, I claim. Let's see how. N people in the class, each having at least 1 friend. Each having at least 1 friend, I claim that there must be at least 2 amongst you with the same number of friends. Right? Clear? Obviously, in this case, you realize that the choice of pigeons, you are the pigeons. You are the pigeons. Right? Now, let's figure out the pigeonholes. Let's figure out the pigeonholes. One thing do you realize that the number of friends, there are n students in the class, right? There are n students in the class. Now, number of friends that could be there, either 1 friend, a person could have 1 friend or 2 friends or 3 friends or n friends, at best n friends. right? Number of friends could be 1, 2, n minus 1 friends. Sorry, n minus 1 friends. Yeah, you have to exclude yourself. So they can be at best n minus 1 friends, 1, 2, 3, n minus 1 friends, right? So this is the pigeonhole for all the pigeons who have 1 friend. For all the pigeons who have 2 friends. For all the pigeons who have 3 friends. For all the pigeons who have n minus 1 friends. Yes or no? Right? How many pigeonholes are there? N minus 1 pigeonholes are there, right? All people with 1 friend will be dumped here. All people with 2 friends will be dumped here. 3 friends dumped here. N minus 1 friends dumped here. Right? Which means now how many pigeons are there? N pigeons. N pigeons. So number of pigeons more than the number of pigeonholes? That means there must be at least 1 pigeonhole, call it J, with more than 1 pigeon. There must be at least 1 pigeonhole, call it J, with more than 1 pigeon. That means there must be at least 2 amongst you having the same number of friends, J say. There must be at least 2 amongst you having the same number of friends, say J. Yes or no?
Yes, sir.
Pigeonhole principle, right? Let me extend this idea. Let's say, so for sure, if there is a group of n people, and each has at least 1 friend, then there must be at least 2 people with the same number of friends. That's guaranteed out of pigeonhole principle. Now I change this. I say, let's say if there is a person with no friend, then also the same thing will hold good. Reason why? Say no friends plugged in here. Now say there is 1 person with no friend. Dump him here. Dump him here, the person with no friend. Hatao. The remaining n minus 1 people, the remaining n minus 2 people, n minus 2 pigeonholes. Now there would be remaining n minus 2 pigeonholes to accommodate n minus 1 pigeons. Same problem then. Therefore there must be at least 1 pigeonhole with more than 1 pigeon. Very good. Because now if 1 person is removed, then how many people remain? So what is the maximum number of friends anyone can have? N minus 2. Got me? So if you exclude, so if there are 2 people, also exclude those 2 people. Then also you will have the same equivalent problem appearing for you, right? So if there are n people in a class, unconditionally I can say that there must be at least 2 people with the same number of friends. That's guaranteed. Is that all right or not? Right? Let me give another application of this. Right? Suppose I give you n plus 1 integers, not consecutive, n plus 1 integers. Right? There is a set S containing n plus 1 integers. Now I claim that in this set, there must be at least 1 pair A comma B. There must be at least 1 pair A comma B in this set. That means 2 numbers in this set must exist. There must necessarily be 2 numbers in this set such that the difference of those 2 numbers is divisible by n. I have a set of n plus 1 integers. I have a set of n plus 1 integers. I then claim that there must be at least two numbers in this set. There must be at least one pair A and B such that A minus B is divisible by n. Such that A minus B is divisible by n. Look, there are these numbers. Say T1, T2, T3, Tn plus 1. These are these numbers. In this set, I claim that there is a pair AB such that A minus B is divisible by n. Now, realize that when you divide a number by n, what are the remainders that it's capable of leaving? 0, 1, 2, up to n minus 1, right? When you divide a certain number by n, the remainders are these following pigeonholes. Remainder 0, then it will be divisible by n. Remainder 1, then it will be divisible by n. So these are the set of remainders. Remainder 2, remainder n minus 1. Yes or no? How many possible remainders? Abey, n remainders, n possible remainders. 0 to n minus 1 is n possible remainders. That is n pigeonholes. Now, these are my pigeons. These numbers are my pigeons. These numbers are my pigeons. I take this number T1, I divide by n. It will leave a certain remainder. So, based on the remainder T1 leaves, I assign it to one of these pigeonholes. T2, I divide by n. Remainder that it leaves, based on that, I assign it to one of these pigeonholes. I do that for all the n plus 1 numbers. How many pigeonholes? How many pigeons are there now? N plus 1 pigeons? There are n plus 1 pigeons. That means there must be at least one pair producing the same remainder. Number of pigeons are n plus 1. Number of pigeonholes are n minus 1. N. Number of pigeonholes are n. Therefore, there must be at least one pigeonhole with more than one pigeon. Yes or no? That means there must be one pigeonhole, say J, which accommodates two pigeons, two or more pigeons, which could accommodate two or more pigeons. That means that could accommodate a number A and that could accommodate a number B at least. At least two numbers A and B belonging to this set would produce the same remainder when divided by n.
One whole will accommodate one pair, right?
Huh?
One whole will accommodate one pair.
No. I'll repeat. I'm so sorry if my communication went wrong. All that I'm saying is, any number when divided by n will leave these remainders, n remainders, right? So I divide each of these numbers by n, and based on the remainder that they leave, I assign these numbers to the corresponding pigeonholes. So it's not about a pair, it can be any numbers, right? Because, so now, amongst these, there are n plus 1 possibilities, but they have to be accommodated in only n pigeonholes. That means there must be two belonging to the same pigeonhole, at least two belonging to the same pigeonhole. That means let's say there are two numbers A and B that leave the same remainder J when divided by n. If there are two numbers A and B leaving the same remainder when divided by n, that means their difference must be divisible by n. If they leave the same remainder on dividing by n, that means their difference must be divisible by n. Yes or no? Right? So there must be a pair amongst n plus 1 such that the difference is divisible by n. Clear?